Okay, so we need to do the square root of 1320 divided by 45 equals, and then square root. And we get our time, which we recognize from the correct answer down here, 5.416 seconds. The next question is, how long will it take the racer to travel 300 feet? Well, we just answered almost that exact same question. In this problem, it would change from a quarter mile to 300 feet. So we would just do 300 divided by 45 equals, and then square root function again. And you can see we get 2.582. And that may seem odd that 300 feet takes 2 seconds and a quarter mile, which is 4 times as much, more than that, only takes 5 seconds, double the time. But if you take the time to graph our functions, you'll see that their growth rate is extremely fast. So that would be the acceleration coming into play there. The last part would be, how far has the racer traveled when it reaches a speed of 172 feet per second? Okay, we need to deal with this, but what we have is a position function. They're definitely asking us for a position, how far has the racer traveled, but what they're not giving us is a time. They're giving us a speed, and I need a time. So if I go back up, I can see that there is a velocity function. That will give me speed, and that takes a time, but I can solve for this time. So the speed can be v, and then I would just solve for t. So let's try that. Move back down here. So the speed would be v. So 172 is equal to 90t. And I just need to solve for t. So t is equal to 172 divided by 90. Let the calculator go. Clear. Okay, 172 divided by 90. So 1.911 seconds. That's a lot of ones. They tell us not to round, so let's keep this in our calculator. I'll just move over here. Okay, so this is my t, and I have a position function that I can plug it into. So what I want to do is put this t, get a different color. I'm going to put this t into this function. So I can just do that directly in my calculator. I need this number squared, and then times 45 equals 164.356, or 164.356 feet. All right, I hope that helps with that problem. It was a lot of our definitions in one problem, and this going straight from acceleration to position can be very misleading. Also, we're so used to dealing with dirt problems, or the d equals rate times time, that we can forget that now we're in calculus. We have acceleration, and we can't plug straight into those constant variable problems.